Good everyone, my name is Graphics. In today's video, we'll be solving a problem involving bearing and distances. And the question goes like this. It says, an aircraft takes off from an airstrip at an average speed of 20 km per hour on a bearing of 52 degrees for 3 hours. It then changes course and flies on a bearing of 28 degrees at an average speed of 30 km per hour for another 1.5 hours. Find A. Its distance from the starting point. B. The bearing of the aircraft from the airstrip. Solution. Now we have to draw the path at which the aircraft takes. First thing and first is that you draw your 4 cardinal points, and bearing will move in a clockwise direction. In some cases, most people go anti-clockwise, but we move in a clockwise direction. This is the North Pole here is 0 degree. The east here is the 90 degree. The south here is 180 degree. The west here is 270 degree. Then back to what? To the north is 360 degree. So your north can either be 360 degree or 0 degree. So we move forward. Now the question says that the aircraft will take this point here that I marked here should be my point what? X. You can take A, B, or C depending on what you want. So this is what? Point X here. So the aircraft, that is point X, is our airstrip where the aircraft is taking off from. And it takes off with an average speed of 20 km per hour, right? On a bearing of 52 degrees for 3 hours. So your most important thing you need here is the direction, which is in degree, right? So you say 52 degrees. So if you start from 0 degree here, right? 52 degree falls from here to here, right? You measure with your protractor if not, or you can just use your normal idea. Can you see that? So I will come at that point where I end. I'm going to put another 4 cardinal point this way. And remember, this will be 0, 90, 180, and what? 270 degree. Are we together now? So that point will be our point Y. Now, we need to know the distance. We're not given the distance, but we're given some parameters that will ensure we find the distance. And what are the parameters? We have the distance, right? We have the speed, which is 20 km per hour. And we have the time, which is what? 3 hours. Now, since we're working with hours, we know that our speed is equal to what? Distance over time. So if I input the value of my speed here, which is 20 km per hour, equals to my distance, which is what we're looking for, all over the time, which is what? 3 hours. So if I cross multiply, my distance now give me 20 times 3, and that's going to give us what? 60 kilometer. So the distance from X to Y is what? 60 kilometer. So I will put it here. Now the next thing is, the question moves further. It says, it then changes course and flies on a bearing of 28 degree at an average speed of 30 km per hour for another 1.5 hour. So the most important thing here is 28 degrees. So you come to this point Y here, and we are going in a clockwise. So this is your 0. So a little bit away from your 0, an angle of what? 28 degree, right? To the next point, which is Z. Is that taking? So that is my 28 degree we have there. Now, doing that, we need to get the distance also. So where I end at 28, where I end, I'll call that point my point Z, and it also have my 0, 90, 180, and what? 270 back to 0, which can also be 360. Now, one thing you need to know is we're given the speed again to be 30 kilometer per hour, right? And the time to be 1.5 hour, that taking, which is saying 3/2. So we know that our speed is distance over time. So the speed here, 30 kilometer per hour, is equals to the distance all over what? The time, which is what? 1.5 hour, and that is approximately 1.5 hours, right? 1.5, you divide 3/2 because 2 times 1 is 2 plus 1, 3/2. So this is 1.5, 1.5 hour, right? So if I could multiply, I'm going to be left with what? 1.5 hour, which is 1.5, multiplied by 30. That's going to give us what? 45. So I'll put my 45 kilometer here. The hour will equate the hour here. So we have 45 kilometer. So this is what we have here. Then we will now close the part. We'll close the loop because the question says we should find the distance from the starting point. That means the distance from X to what? To Z. X is the starting point, and where the aircraft is at point Z. So you just use a line and connect from Z to what? To X. So that's what we're looking for. So if this is X here, here will be small letter x. So small letter x equals to 45. If this is z here will be small letter z equals to what? 60 kilometer. And if this is y here small letter y, which is what we're looking for. Are we together? So I'm using the capital letter to represent the angle and the small letter to represent what? The distances. You can virtually use A, B, and C if you want to, or P, Q, R if you want to. Is that again? So we move further. Now, if you look at this, we cannot really see the angle here because it is forming a triangle here. We don't know what angle it is. But one thing for sure I know is that from here to here is going to be what? 52 degree, and the remaining here is what? 38 degree. Is that again? So if you look at this now, I told whenever you have this shape, like a Z shape like this, is that again? We'll call that alternate angle. Whatever is here will be the same thing as here also. So since there is 38, the angle here is also what? 38. Is that taken? And the difference one between 270 and 360 is 90. Or we can say since this angle, the north here and the west here is 90 degree, so I'll put my 90 here. They are perpendicular to each other, so it's 90 degree. This is another angle here. Then this 28 we have here also. So if I add everything all together, 38 plus 90 plus 28, all will give me what? 156 degree. The first thing we have successfully drawn out the free body diagram of that movement. Is that again? So the next thing we are going to be doing here is to calculate for what? For the distance from the starting point. Now there are many ways you can actually achieve this. But one of the ways is that we're going to use cosine rule, right, in getting the distance from Z to X, right? And why am I using cosine rule? One of the law involving using cosine rule is that when you have two sides, which is 60 and 45, and an included angle, which is 156 degree, you're going to be using what? Cosine rule. So look at the two sides here, X and Y. Then the angle in between them is 156 degrees. So when you have two given side and one given angle in between them, you're going to use what? Cosine rule. And the rule says that I can say since I'm looking for the distance of y, right? So I'm going to say my y square is equals to z square plus x square minus 2zx cos y. That's what we have there. That is what we call the cosine rule. So whatever you are looking for, that is what you put outside. The remaining will be inside. So if I start inputting my parameters here, right, I will now say that my y will now be equals to, when the square crosses the equal sign, it become the square root of 60, square root of z is 60, so we have 60 square, plus x is 45, so we have 45 square, minus 2 times 60 times 45, cos 156 degree. Is that taken? So I'm putting my parameters since we have the value for x, y, and z. Is that taken? And the angle here in front of the cos is 156. Now if I move further, my y here will now give me the square root of 60 square is 3600, plus 45 square is 2025, minus 2 times 60 times 45 is 5400, and cos 156 is minus 0.914, right? So this will now give me the square root of 3600 plus 2025 will give us we have this to be 3600, right, plus 2025. We have this to give me 5625, right? 5 what? 625 as the addition of both of them. Then 5400 times minus 0.914 will give us what? Minus 49 minus 4933.15. So when you multiply the minus with this minus here, to become what? Plus. Is that again? So we now have this to give me y will now be the square root of, if you add everything all together, the square root of 10,558.15. And this will now be, y will now be equals to the square root of 10,558.15 is what? 102.75 kilometer, which is approximately 103 kilometer. So that is distance from what? From X to Z. Now question B says we should find the bearing of the aircraft from the airstrip. And the airstrip is the starting point of the journey, right? While the aircraft is where the point it is at the moment before it gets back to the airstrip. So we want to look for the bearing. Now looking for the bearing in this case, we are going to make use of sine rule. And the sine rule, since the variable given on this diagram is x, y, and z, so we're using capital letter Z for the angle, capital letter X and capital letter Y respectively, while we're using small letter x, y, and z for the distances, as you can see on the screen. So the sine rule says that small letter y divided by sine capital letter Y, which is where the angle, is equals to x over sine x is equals to z over sine z. You know the one in front of the angle is capital letter, while the one on top are small letters, just to differentiate both the angle and the distance. Now the value for y is 102.7 divided by sine, the value for the angle at y is 156, equals to the value for x is 45 divided by sine of the value for the angle at point x is what? Not given, equals to the value for z is 60 divided by sine the value of the angle at point z, which is what? Not also given. Now since we are looking for the angle, for the bearing of the aircraft from the airstrip, and we know the airstrip is point what? Point x. So I'm going to take 45 over sine x, and also I'm going to take one of the two remaining parts. So it can be 102.7 divided by sine 156 or 60 all over sine z. But because of, if you look at 102.7 divided by sine 156 is complete, there is no unknown there. But if I should now go to 60 over sine z, I'll be having sine z, which is unknown, and also I'll be having sine x, which is unknown. So it will make my work more complicated. So I'm going to be taking the 102.7 over sine 156 and also 45 over sine x. so that we'll only be having one unknown. Is that taken? So now if you look at this very well, I am going to cross multiply. We'll be having sine x coming up, while 102.7 replacing it. And similarly, sine 156 will go up to multiply 45. So we'll be having sine x equals to 45 sine 156 all over 102.7. So when you look for 45 sine 156 divided by 102.7, you'll be having sine x equals to what? 0.1782. So x here now, if I take sine to the right hand side, it becomes sine inverse. So my x will now give me sine inverse of 0.1782. So the sine inverse of 0.1782 will give us 10.26. So that is the value of x. But what do you notice? The angle x is in between these two triangles here, this part and this part. Are you with me now? And the angle at that point there is given to be what? Is given to be 52. The distance, the angle from this point to the other point is what? 52. Because they said the aircraft leave the airstrip at a bearing of what? 52. Meaning that 52 is in between here. And the value of my x is what? 10.26. So it is in 52 degree. What will I do? I'm going to subtract x from 52. And what's the value of x? The value of x is 10.26. So when I subtract 10.26 from 52, I'm going to be having 41.7 degree. And that will be the bearing of the what? The aircraft from the airstrip. That means when you're standing at point x, at what angle you'll be looking at point Z. Is that taken? So that is what it means. So we have successfully solved the problem that is displayed on the screen. So if you have found the video helpful, please don't forget to like, subscribe, and also share the video. Thanks for watching.